Hi everyone. In this video, we're going to add Apollo server to our Node application. The first thing that we're going to do is add a few modules here. So Apollo server, as I was saying, that's what we're going to use. However, just one thing to note here is that we're going to use a package called Apollo Server Express, not Apollo server. There is a tiny difference between the two. The Apollo Server Express package lets us use it alongside Express, and that's what we want to do. So if you're looking at Apollo Server's official documentation, it may be a little different. So I suggest you look at the repository for Apollo Server Express. And we're also using Express, of course, the most famous, the most popular framework for writing web applications in Node. We need GraphQL. Now, type GraphQL, it's as I was saying in the past, it's a nice library that allows us to write GraphQL API servers using TypeScript and hence Typeform, and it plays well with Apollo server as well. Cool. And we're also going to add a few dev dependencies, some type definitions. Also, we're adding, where are we? Here, TS node dev, it basically provides us with hot reloading. So having that said, we're going to change our package.json a little bit. Instead of doing yarn start, which does TS node, let's just actually just do TS node dev source index.ts right inside here. So just to kind of give you an idea what would happen in that case, I'm using yarn dev. It runs as expected. If I go over here and hit Command S to save, as you can see, it reloads again and runs the server again. Very cool. Now I'm going to add Apollo server, and as I was saying, the code that you want is here. It's a little different from Apollo server, so just be careful for that. Let's first import everything we need. Oops. So we're going to import everything we need. And one thing that I like to do is have a empty line between the imports for packages for the libraries that I'm using and the import for my own code. So it's just easier to see this is my code. And grab a hold of that. Paste it down here. All right, and we'll just save it right away for now and see what happens. Cool. So it's running as expected. Just to go over the code very briefly, I'm creating some type definitions for a query called hello. I'm creating a resolver for the query hello. I am I'm creating my Apollo server. I'm actually applying it as middleware to my Express application, and I'm running my application right here. Now, I'll go over what these mean. So, GraphQL is one of those things that you can benefit a lot from doing. So, going back to what, how, and why, it's one of those things that when you read through the official documentation, the kind of getting started tutorials in the official documentation, which is fantastic, by the way, it it makes sense. It allows you to kind of get a grasp of what it is for and what it is. So it's a querying language that allows you to query for data, exactly the type of data that you want. It makes it easy for you to not overfetch or underfetch data, so on and so forth. That all makes sense, but until you actually try it out, it's hard to understand why you would ever want to use that over the good old REST APIs, right? And in my experience, when I've tried to use GraphQL and learn GraphQL, it was quite challenging. Not so much in the front end side of things, because usually using GraphQL in the front end is very pleasant and easy to use. it actually helps a lot in terms of the front-end developers' productivity, more so than the back-end developers' productivity, in my experience. And when trying to implement or create GraphQL API servers, I found it's quite there are parts that are quite tedious and difficult to actually set up. However, the combination of the libraries that I found and that I'll be covering here finally made it actually pleasant to work with. So hopefully you'll find it that way as well. And a few things to note here, definitely try to learn what GraphQL is first, but quickly to catch up with things, query, you can think of it kind of like a GET request. There's also another term called mutation. You can think that as a post request, put, delete. Not really, this is a very, it's an oversimplification or of things, but it's just an easy way to think about it. Resolvers, in a way, especially later on, you'll see that you can almost think of them as controllers. Basically, what they do is they resolve incoming requests into the response that you want to give out. Right? So that's what a resolver does. And yeah, so those are some of the GraphQL terminologies. And as you can see right here, it says server is ready at this particular location. And if you actually follow that URL, you will be given something that looks like this. Right? Let's actually remove that. Now, one of the nice things about using Apollo Server or any other framework for GraphQL is it comes with some dev tools that are fantastic to use out of the box, and this is it, right? So as you can see here, we're defining a query named hello, and we're saying that it should return. The response for that query should be a string, or part of it at the very least. And the way that we will do it is by saying, okay, if when we receive a query hello, we're going to give back a string that says hello world. So if you go over here, you can click on schema, and it actually will show you all of the queries and mutations that you've defined and information about them. So you can actually go ahead and try to send a request here. Let's send that. Boom. That's a GraphQL request, and this is the way that the response will look like. So let's make a few changes right here, because I mean, hello world examples are good to just kind of see it working, but not really useful. So let's try to imagine ourselves creating a query for fetching users. Let's start with user. Right? Now, if this was just a string, maybe we say this is a user, and that's all that we're doing, which is cool. When you're updating your code here and you want to test it on your kind of dev tool, remember to refresh it as well. Now, if you try to send this again, it will not work. It's going to error out saying cannot query field hello on type query, because the query, there is no query named hello. And you can check that from right here. As you can see, there's only a get user query, no longer a hello query. So instead of hello, you can do get user, send that request, and you get that back, right? Cool. But now let's actually try to actually send back a user. So instead of a string, we might try to do something along the lines of await user find one, right? And to use await, you can do async, right? Now, this is not going to work because obviously this is not a string. It will be user. But even then, this will probably not work. Let's see. It's terminating unhandled promise rejections, blah, blah, blah. It could be that instead of doing that, we need to say it's a promise because, well, the thing that we're returning is a user object that we're trying to find from a database that may fail, and this whole thing itself is actually a promise. So this might work, short answer, it's not going to. Because there's a lot of things that you actually have to do. You have to make sure that you're handling promises being rejected, and this is just a simple example here, but if you were to want to write something that looks like get users, and it's actually going to be a promise of an array of users, and this looks more so like find, something along the lines of that, you actually need to specify how the schema very, very well. Right? So what am I talking about? Let's take a step back and think about a few things. What are some of the things that you need to think about when creating a API server? Right, so first thing is, what does a valid request look like, right? What does a valid request look like? Then, what do we want to send back? What do we want to send back as a response? And then the third thing is going from basically 1 to 2, right? So what does a valid request look like? And what's the kind of, what do we want to send back as a response? And most of the coding would be done in step 3, which is going from step 1 to step 2. Like, okay, so how do we actually get there, right? When you're thinking about REST APIs, what does a valid request look like? There are many things that you want to consider. Is it a GET request, POST request, blah, 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 and there's the endpoint. We try to create these rules and patterns through a few things, endpoints being one of them. So maybe it looks something like user, and then you need to get the user ID, something along the lines of that. If it's a POST request and you are trying to create a user, then you also need a request body to follow a particular shape. So maybe along the lines of email, there's going to be a password, maybe name, so on and so forth, right? And maybe that also has to actually be wrapped up inside data, like so. Right? I mean, as a developer who is creating these endpoints, it's up to you to actually decide how it should look like. But as the consumer of these API endpoints, you need to know how to send those requests. So you need to know what the rules are for the endpoints and the body and so on and so forth. And also when you're actually dealing with responses, you also want to have some sort of a pattern or rule as to how the response will look like. Right? Maybe you would have experienced being the consumer of API endpoints. If you can't really predict how the response will look like, if it's all over the place between different endpoints, then it's just hard to use, right? So pleasant to use APIs are those that like follow a certain pattern, and you can kind of predict how to send a request, although you haven't read the exact documentation that talks about it. But if you have for other endpoints, you can kind of predict how to write or send a request for a different resource, and you can also predict what the response will look like, right? So we need to design this in a way that is predictable and so on and so forth. Now, one of the good things about GraphQL is that to an extent, it handles that all for you, because for the most part, a GraphQL request, a query or a mutation, for the most part will follow, so the response will follow how the request looks like. And that alone is just quite refreshing, and it's quite amazing to be on the other end, be on the end of consuming API as a front-end developer, right? So that's one of the things that we will do as writing GraphQL APIs. However, having that said, now these two steps are done in GraphQL by creating, as you can see here, basically schemas of what the request should look like and what the response should look like. And resolvers are basically handling number 3, how that works. Now when we're doing that, it's actually quite tedious in my experience to create these schemas. So if all you're using is Apollo server, you would have to do it the Apollo server way. But for me, I found it that it's a lot easier to do so when we use a library, different library to handle that for us. So that's what we're going to do by using type GraphQL, right? So let's, for one moment here, we're going to ignore some of this code here and try to use type GraphQL. The first thing that you will do is edit our user.ts. We do this, copy paste that over. Now, what am I doing over here? So this can be a little confusing because basically we have a single class, but we're decorating that single class with decorators from two different libraries that serve two different purposes. So the decorators that you're getting from Typeworm, just think of them as it relates to the database. It relates to models and methods that come with models. Now, for the decorators that come with type GraphQL, as you can imagine, it relates to type GraphQL. So it relates to requests and responses. So we're going to decorate our class with the object type, and we're also going to decorate some of our fields with fields, and in this case, all of them. So by doing so, what we're saying is that, okay, in our response, if we ever create a query or mutation that should send back users or a user or a user, then these should be available fields. That's basically what this is doing. Great. So basically, type GraphQL under the hood would be handling a lot of that schema creation for you. So all you really need to do is just say, hey, ID should be a field that is available in our GraphQL API for either making mutations or making queries. Going back right here, we're also going to change a few things about our index.ts. Copy that, paste it over there, and also copy this over. So we are going to, where is it, server apply middleware. So this part we're going to remove, paste it. Is there anything that says, nope. Only thing is we are no longer using GQL, remove that. We'll save it, and let's see if this will work. Great. So let's just take a look at the code here. What we're saying is we're getting a decorator called resolver from type GraphQL. As you can imagine, what that does is, given a class, it'll actually handle everything that we need to do to make it a resolver. So we're creating a class called getUsersResolver. Inside that resolver, we have a single query, which in this case, what it's supposed to return is an array of users. And that query, the name of that query is getUsers, and it also technically returns a promise of an array of users. And the way that we would do it is by basically saying return user.find. Now, we're also creating a schema. This build schema method is coming from type GraphQL as well. Like I was saying, it handles the schema creation for you and make it a lot easier. So we have resolvers, and we're adding one resolver into that. And Apollo server, we're creating one using that schema built from build schema method from type GraphQL. All right. So let's go back to our playground right here. We're going to refresh, look at our schema. Now our schema, the dev tools, look a little different. The name of the schema, the query, is the same, get users. But if you click on this, it'll tell you all the information that you need. Basically, it's saying get users. There's not much else that you need to know in terms of sending that request, other than the fact that this is what you can expect, what is available for you to query. These are some of the things that you will be able to get as data from this endpoint, or sorry, not endpoint, but um, the query. So what we can do here is, I think the only difference is what we were trying to do is get users before, but right now it's get users with S. So I just add that in, and we're gonna run it. And then you might see something that looks like this. Get users of type must have a selection of subfields. So what that means is, this is, I guess, the only, it's a tiny bit tedious, especially if you're coming from REST, using REST APIs, and it's your first time getting into GraphQL, because when you're using RESTful APIs, you just send out a request, a GET request, and you just get the entire data, right? Whether or not you need first name or last name, let's say you only need the email, but you're still going to send a GET request, and you would expect to get, very likely, just like the whole data, the whole thing, right? But in GraphQL, one of the features is that you can selectively choose which data that you want to get back, right? So what you need to do here is say, okay, I'm going to send a query, get users query, and the type of data that I want from that is, let's say, only the IDs. That's all I'm interested in. Then it's going to send back exactly that. But of course, if you want everything, then you can ask for everything. And there we go, right? Hopefully that makes sense, and hopefully this kind of gives you an idea of the advantages of using GraphQL. I mean, we're just getting started, but hopefully, yeah, you like what you see. Is there anything else that I wanted to do? No, that's pretty much it. In the next video, we're going to create a React application and then add Apollo's client to it, and finally actually see it in action, sending a GraphQL request from the React app to our Node application and get that data back. All right, until then.